Good afternoon. I'm glad to be in front of you today in this beautiful city of Lisbon. I'm Mathieu Houpert. I'm Innovation and Business Development Manager at Parker. Along with my partner, David Gyulnazaryan from Impleon, we'll show you today how alternative materials can address the data center industry challenges. And for that, we'll take the example of the quick disconnect in a liquid cooling system. So the data center industry faces three major challenges. The first one is the sustainability. This was shown by OVH very well this morning for sure. And there is a report from the French organization ADEME that shows that data center carbon emission represents 3 to 4% of the worldwide emission. By comparison, this is more than the global aviation. But this is only the visible part of the iceberg, because what we will see in this presentation is that there is also embedded carbon into the data center hardware. The second challenge of the data center industry is the efficiency, because of course all the actors would like to have the highest IT power with the minimum energy consumption. And they would like as well to densify the IT power, to have the maximum IT in a minimum space. And the last challenge is about the scalability. The emerging of AI is increasing the needs for data center. And this rapid growth requires a rapid response from the ecosystem and also a very reactive supply chain. So we thought that the quick disconnect was an interesting example there because it's an important component in a liquid-cooled data center. Because, sorry for that. Because it facilitates the server installation into the rack, and it eases the maintenance with safe dripless disconnection. And also, even if it's a very small component, it could represent about 90 tons of equipment in an hyperscale data center. So that starts to be a quite significant value. So why do we think that advanced materials and especially advanced polymer can support to address those challenges? Because and that's what we will see in this presentation, they could be more sustainable than metal solutions. They comply to OCP requirements and specifications, such as the robustness, the material compatibilities, and so on. They allow also a more efficient design with reduced cost. They are intrinsically corrosion resistant, and they could be flame resistant as well. And their manufacturing process allow high cadency rates that could ease the data center deployments. So about the challenges, let's start by the sustainability. A polymer quick disconnect will weigh about 60% less than its metal equivalent. And we have performed a product lifecycle assessment to compare the traditional solution with polymer ones. And at the beginning, I'll be honest, we had a doubt because some people around us told us, are you really sure that a polymer solution is more sustainable than a metal one? Because when people think about polymer, they have in mind, for example, the plastic bottles or the single-use packaging. But those kind of products has a very short life cycles. But here, the product will last the same time. So you can see in this analysis that we can, by using the polymer, we can reduce the carbon emission, the embedded carbon emission by 55%. And we were surprised as well to see that we can reduce by 60% the use of water and also reduce the human toxicity by 70%. In this analysis, we decided to exclude the use phase and to treat it separately. So that's what we will see in the next slide. So you should know that the quick disconnect has impact on the flow and the pressure of the cooling circuit. The valve component inside generates pressure drops that will require additional energy to maintain the system at a certain flow. We have, of course, very efficient metal quick disconnects, but we would like to go further and to see the next steps. And what we can see in this simulation, in this comparative simulation, is that the polymer is a lever to increase to reduce the pressure drop. So you can see here that, for example, by this simulation, we can see that we reduce the pressure drop by 10% using the polymer. And the big advantage is that this is a competitive solution without sacrificing the product must-have. And about the scalability, so the polymer, the advanced polymer, has high cadency rates that will allow higher production, for example, than machining or turning operation. Also, one thing interesting is that the polymer is a good lever to automate the assembly of the product. And one important aspect is that with 60% less weight, all the handling operation will be simplified. And for example, if you take a single manifold of a rack, this could represent about 4 kilograms. So that means, for example, maybe less people to be able to assemble the rack and also a better safety. So now I will let my partner, David, show you a more macro overview at the data center level. Thanks, David.
Thank you. So let's evaluate that impact on 3 levels. Let's start from the rack. So in this picture, you see the rack with 72 OCP servers, liquid cooled. And what we achieve, we reduce the pressure drops on the rack level, just 5 kPa. And but we reduce a lot on CO2 emissions on quick disconnectors. It is 50%, 57% less. And also we reduce 60% of weight. And that represents 70 kilograms per rack. But when we will go on the level of the modular data center with 16 racks, then we see the reduction on energy consumption. It's energy bills, and also CO2 emissions if your energy grid is based on fossil fuels. But also we have a lot of almost 2 tons on CO2 emissions reduction, just on quick disconnectors, and 267 kilograms. It means that this weight can be used for the useful equipment for IT servers, as an example. And next level is hyperscaler. Here you see an example of underground data center, about which you can see more tomorrow. But the impact in that case is in energy consumption is 306 megawatt hours per year. And that is a lot, only on quick disconnectors. And also we have 397 tons of CO2 emissions reduction. That means that it's approximately like 400 houses which heating for the whole cold season. It's a lot for just quick disconnectors. And also, which is important for underground data center, we reduce 54 tons of the weight. It means that we can put 54 racks more. And 54 racks, it's like a small data center. So it's a huge. So this is the impact of only quick disconnectors, which play a role in the rack between servers and manifolds. And also, I just want to add that there is a potential to collaborate with OCP, data center, facility sustainability work stream, and cold plates and door heat exchangers. Thank you.
Yeah.
Mathieu?
Thanks, David. So we strongly believe that that the high-performance polymer can address the data center industry challenges. But we still have some ways of improvement. So, for example, working on the increasing the recyclability, and before there was the case of, for example, reuse case, retrofit, and so on. So this is also interesting way. Maybe the use of biosource material as well could be something interesting or interesting lever. And also work on the packaging. Again, the packaging is sometimes not sustainable, so there could be, again, some improvement on it. We have to protect our products during the delivery, so this could be a good lever. And yeah, so you have anticipated those one, but the call to action for sure. We would like to review this topic with the OCP team members, along with the cold plate workstream and also the DCF sustainability workstream, and introduce this quick disconnect to the ORV3 team. And we have, so we are the innovation village. We have a demo rack with different partners. We have a wooden demo rack with Parker products inside. So you are welcome to come and see our product. For sure, we can discuss around it. So, thank you very much. Thank you.
We have 3 minutes. If you have questions, welcome.
Hi, I was just wondering, so first of all, my name is Luke and I'm with Cool IT Systems. So I was just wondering how you're finding the performance with the high performance polymers versus metal, right? So I guess that's one of the challenges I would have, is that we have moved away from high performance polymers towards metal, although I wouldn't say they're obviously the same composition as what you're looking at right now. But how do you find the performance of the two in terms of your experience there and perhaps with this report?
Yeah, you mean the choice of the material, of the polymer itself, yes, versus the metal one?
Yes.
So yeah, regarding this choice, so we are aligned with the OCP guidelines regarding what was done regarding the testing. So, but of course there is challenges to validate this, but there are some polymers that are capable to achieve those kind of, for example, chemical compatibilities and so on. So, and I'll be glad to discuss, of course, with you in details.
Any other questions?
Okay.